Hello, this is the Tepid Coder. Right now, what I want to do is show recursion. It's something I've been wanting to do for a while, but there are a lot of ways to explain recursion. Most of the ways that people first introduce it I find to be very unhelpful, because it doesn't really give you a good idea of why you'd want to do it. So, one example people typically use is the Fibonacci sequence, where you have like 1 and 1, and you keep adding the previous two terms. You'll have like 2, and then 3, and then 5, and then, well, I guess 8, and then 12, or 13. And then you'd have, what, 21? You just keep going like that. Anyway, not sure why you'd ever really need to do that for a job, or for any kind of hobby project of your own, but I'm sure someone out there has needed to do it for some scientific reason or something. But I haven't, and probably most people haven't. So, I was thinking of options. Another way you might use permutations, another way you might use recursion is for finding all permutations of a set really efficiently. But again, that's not something you're going to do very frequently. The other thing I thought of was like when working with file systems. Maybe you want to show all the files in a directory. Say you have some folder. Let's call it, directory 1. Inside directory 1 you have file 1, file 2, and then you have directory 2 inside of here. It's like a subdirectory. Inside of that you have like file 3, file 4, right? And down here we're back into this directory again, you have file 5. Let's say that's the whole thing. So maybe you start searching here, you look at all the items, so file, file. If it's a directory, now you have to do the same thing. You're going to do the same operation where you look in, starting from this directory, but it's now starting from this directory. File, file, no directories, you're done. Okay, now we're back into this function, finish, file. So, I've had to do that a lot. That's the most common time I've had to use recursion. But I don't know if it's a great thing to show anymore, because you no longer have to use things in Windows API like find first file A or W, and then find next file A or W. And on Unix systems, you don't have to do open directory, read directory, close directory. Those things aren't really needed anymore. They've been superseded. You can just do include file system in C++17, or if you include boost. And you can recurse through directories pretty easily, or look to the current directory and see if something is a file or a directory without too much trouble. Anyway, because of that, I thought this isn't probably a very good reason to show recursion anymore. It won't be very relevant. So the only one that's still fresh in my mind that I've had to do recently is the flood fill algorithm. And I think it'll be a fun one to code because I can show off some things like bit masks and, bit shifting and anding and ORing, and show a reason to use that to save memory at the same time. So what I'm going to do here is I'm going to implement a flood fill algorithm using recursion, and I'm going to store everything I display within a bunch of bits. So let's do that. Let's say my main function. Okay. What I want to do is I want to have something like a vector, right? I need to include vector. And let's make it an unsigned 8-bit integer. Let's call this picture. Now, what I really want to do here is make an array. Picture equals. And for now, let's start out not using bits. We're going to start out using bytes just to make this easy. I'm trying to think how I want to do this. Really, I want to be able to draw like a picture. Like this, you know? Just like that. Maybe I'll start like this. And maybe that. If I make a point in here, what I want to do is make it so that until I hit a value that's not 0, it's going to keep filling 1s. So it should fill all of these, both these, but if it's a 1, it's going to stop, right? Well, the first thing I need to know is, what is the offset of this right here, or any of these that I want to start on? Well, we have 0, 1, 2, 3, 4, 5, 6, 7. So there's, it's 8 long, and 1, 2, 3, 4, 5, 6. 6 tall. So 8W, 6H. Okay, so if I want to find this, for example, we're on row 0, 1, 2. So 2 is going to be the y, and then what I'm going to have is, for the x, 0, 1, 2. So 2, 2. Well, in order to get here, for every row, I have to multiply by 8. So y is 2, so it's 8 times 2. So it's 2 is the y times 8 is the width, plus 2 is the offset from there. If I said 0 from there, it'd just be right here. 1 from here, 2 from here. So that's where we're going to start. Okay. But the picture, what I want to say here is insert. Really, right now I don't even need to do this. I could just manipulate this directly. And I'm kind of tempted to do that just to make the easiest case first, and then make it more complex later. I have to think about that. And I could do a vector of bools as well, because that automatically bitpacks things. But for now I'm going to stick it into a vector, just so I can expand later. Actually, I'm going to say end, insert the end of the vector. I'm going to say UI array picture, that's the start of it, and then I'm going to say UI array picture, size of UI array picture. So stop once we reach the first out of bound element. So once we get one past this, we'll stop. For that trailing comma. Okay. So what I'm going to need to do here is flood fill. Flood fill. I'm going to say the picture. I'm just going to pass this vector. I'm going to pass, what do I say? The width of it is going to be 8, right? Or is it 9? What did I decide on? Is it 8? Really? 1, 2, 3, 4. 1, 2, 3, 4. Yeah, it's 8. Okay. Just double checking. Okay, so it's 8 is the width. And then I wanted to do 2 for the x. And I wanted to do 2 for the y. So I'm flood filling from there. Okay, and I want to flood fill with 1s. So that's going to be how my function works. So let's paste that here. Let's do void. Let's do standard vector of unit AT. What we're going to say here is we want the width. This is what we're going to multiply for the row. So we can multiply this by the y position. Okay, so now we have, let's do size t x, size t y. Okay, and I'm just going to say 8t. This is what we're filling with. Value to fill with. Right? So I'm going to say if the picture position stx plus sty times st width equals this, then it's already what we want it to be, and we're just going to be done. So return. Otherwise, what we're going to have to do is we're going to say if the picture stx plus sty times st width. Okay, we're going to be careful about this. So -1. Let's see. Not equals that. Then we're allowed to fill it, right? So we're going to say flood fill. We're going to pass the picture. This should be a reference, by the way, so I can update it each time. So flood fill the picture. Keep the same width. In fact, I'm going to keep height as well. Size t, because I want to make sure I'm not overflowing the image. So 8 and 6. Okay. So we have width, height, we have x, y, and this. Okay. So let me think about that for a second. The other thing we're going to need to do is check to see if we've been there yet. I mean, obviously, if it's equal to this value, then we haven't been there yet. But what I'm going to do here is I'm going to say this equals what value to fill with. Oops. So, that. So right here, by subtracting 1 from the position we started on, what we're going to do is we're going to look left. And actually, I don't even need to do this. Every time I visit a point, that's the point I'm going to set. So the function was called. If it's not already on the type we want it to be, then we can continue. Otherwise, we're done. So we were able to continue. That means we can set the current coordinates that we were given. Now we're checking to see if we can look left of us. So if the value left of us isn't out of bounds. So this check would be if stx is greater than or equal to 0. Actually, if it's greater than 0. If we hit 0, then looking 1 left would be -1, which is invalid. So if we're allowed to look this direction, then we'll try to do so. But if we've already visited it, then we're not going to do it again. Okay. So now what we're going to do is, if stx is less than, and it's going to be st width minus 1. Because if it's equal to the width, then it's already out of bounds. If it's equal to width minus 1, then bringing it up to the width will make it out of bounds. So then we're going to increase to get there. Okay. So now, same check for the y. If y is greater than 0, then subtracting will only bring us to 0. But if we're already at 0, then it's bad because we'll be at -1. So in this case, we're going to look at sty minus 1. We can look back from there. I actually need to write that too. -1. Wait. Okay, right here, I need to look at this being +1. Over here, we're going to look at this being -1. Okay. And finally, we have a case where y needs to be less than st height minus 1. Again, if it's equal to the height, it's already out of bounds. So if it's equal to height minus 1, we're already at the last thing, and it'll bring us up to height, which is out of bounds. So it has to be less than height minus 1. Okay. Right. Yeah. Cool. Okay. This right here, +1. So we're checking to see the right is not already the value we're trying to fill it with. Okay, that's good. If it's not, we can go up to the next line. So what's going to happen here is this function is going to get called with some coordinate we want to flood fill from, and then once it's called, it's going to say, hey, is it already the thing we're trying to flood fill with? If it is, give up. We're done. We'll assume it isn't, so we're going to keep going. So we're going to fill this pixel, or this value in the array, I'm pretending they're pixels on the screen, with whatever we said to fill it with, 0 or 1. Okay, now we're going to look to the right if we can. Actually, we're going to look to the left if we can. So if there's a pixel left of us, imagine we have, like, I don't know, xxx, xxx. If we're right here, we can't look left. But if we're right here, we can look left, and we'll end up on this one, right? So that's basically what's happening there. And over here, we're saying, well, we have 0, 1, w, that's our width, right? So if we're at, actually not even width minus 1 is where we end up, right? Okay. Because remember, the indices of an array start at 0. So if it was like 1, 2 width, right, that would work, but it starts at 0, so it's width minus 1. So if we're at width minus 1, we're already at the end. So it has to be less than this. Less than width minus 1. Width minus 1 would be 1 right here. So then we can move to the right and be fine. So that's what's happening there. Over here we have xx. Let's say greater than 0 for the y. So if we are at 0, let's say we're at this, we can't move up this direction, right? This doesn't exist. But if we're over here, we can move up, right? Because moving up from here will bring us right here. So that's fine. That's what's happening there. And for the final check we're doing here, we're checking to see whether we're already this far down, right? So height minus 1, again, 0, you can imagine 1, dot, 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 you know. Then we have height minus 1 is where it ends. So if we're less than height minus 1, this would be the first one less than that, let's say, then we're allowed to go down, right? Because we just end up on height minus 1. But if we're already on height minus 1, which should be right here, something on this row, then we'd end up down here somewhere, which doesn't exist. Okay, yeah. I'll even label these real quick. So, if the value to the right of us isn't out of bounds. If the value to the value above us isn't out of bounds. Okay. If the value below us isn't out of bounds. I'm actually going to make this I over here capital since the rest are. Okay. So what's going to happen is, if it's able to look in these directions, it's going to start the function over again with the new coordinate. So if we can move left, we're doing it again, moving left. If we can move right, we're doing it again, moving one more to the right. If we can look above us, we're moving down, going up towards the top of the buffer, right? If we can move down towards the bottom of the buffer this way, then we're adding one. And what's going to happen is, for each of these, you can imagine the function gets called again. We're going to say, have we already filled it? If we have, we're done. Stop there. Otherwise, fill it, and then check left of that. Check right of that. Check above that. Check below that. So for every single time it's called, it's going to try and call itself 4 more times. And every time it hits a dead end, it's going to stop in that direction. So let's say we start right here. It's going to say look left. Is it valid to look left? Yeah, we're not going out of bounds. That's fine. But it's a 1, so it's going to stop. But we're in the next function call right now, so let's see. I'm trying to think here. So it's already 1, so it'll stop. So if it already stops, we're going to end there, like, because right here. Okay. So now let's say it also tried to look to the right, which is right here. Can it do that? Yes. And when it sees that, it'll try to look to the left, but it's already filled, so we're stopping. And it'll try looking to the right of that, which it can do. And then that also can look left, but it's already going to be 1 at that point because it filled it, so it's going to stop. Look right, can't do it, it's already filled. Look below us, or actually above, which it can't do, so it's going to stop. It'll look down, which it can do, so it'll stop. So that one's done. So now we're still going to finish this. This looks to the right, that already happened. It's going to look up, can't do it. It's going to look down, it can do it. Now from here, it's going to go left, and then that one will do its same checks, you know, here, already filled, up, that'll work. It'll have to stop because it's out of bounds, go back over here, you know. It's just going to keep doing that, spiraling around for each of these points until it hits all of these ones that are bounding it. So what I'm going to do now is I'm going to carefully print these out in a way that you can tell that's like an image, right? So I'm going to say for, geez, let's do this, I equals 0, I less than, let's say, 8. I'm going to pretend these are pixels, I'm just going to refer to them that way. So 8 pixels per row. So, yeah. And the outer one's going to be size t, say j. In fact, I'll say y and x. This will make more sense when we're actually going through it. Equals 0, st y is less than 6 rows, st y plus plus. Okay, so for each of the 6 rows, okay, and over here, we'll print a line break every time a row ends. Otherwise, we're going to print out, let's say, just C. Yeah. I'm going to say the picture position sty times 8 plus stx question mark. So if it's a 0, or if it's a 1 rather, then print 1, otherwise print 0. Okay. I think that's pretty good, so let's try that. Compiled the first time. Okay, here we go. It filled it, see? Now I'm going to show what it looks like before I fill it as well, so you can see that it actually did something. In fact, I want to say all of this needs to be put in its own function. I'm going to call this show picture, right? I'm going to say standard vector of type uint by reference. It's going to be const. I don't need to update it. So v for vector, I'll call it picture actually. And then we're going to say size t, width, okay, size t, height, okay. And I'm going to dump that in here. We already have v picture, that's good. I kind of want to speed this up a little bit because this is a really dumb way to do it. Every time you index into a vector like that, it has to call a function. I kind of don't want to call a function every single time. It has a subscript operator overload I'm calling. So what I'm actually going to do here is I'm going to say unit8t pointer p, okay, equals, I'm just going to say the picture.data. Okay. And every single time I print one of these out, I'm just going to say lpui8p++. Go to the next element of the vector. And over here, I'm just going to print out lpui8p dereferenced. So if that is set, if it's 1, or it's not 0 basically, then I'm going to print a 1. If it is 0, I'm going to print a 0. And every single time I move to the next element inside the image. Okay. So we have 6 and 8. This is going to be the height. This is going to be the width. Okay. Let's grab that. I want to show it before I flake fill. Okay. We just have the picture. Okay, we know this is 6. Oh, sorry, this is 6 right here. And the width is 8. So width, height. Okay. Good. And I'm going to do it again after we flood fill. So it'll be really obvious. Okay, didn't like that for some reason. Conversion between const to... Okay, I see what happened. Yeah. So I passed the vector in as const, which means all the data inside it is also const. So if I have a const vector, it's like the vector is full of const u8 int t's like that. So what I really need to do here is make this a const pointer. Okay. There. You can't really see where one starts, one stops very easily, but that probably should be the first, right? So 1, 2, 3, 4, 5, 6. Yeah. So that's the first one. You can see this whole interior isn't filled. And in the second one, starting here, you can see the whole interior is filled. So that worked. Something else I can do, though, to save some memory, is instead of having 8 bits for every single one of these zeros and ones, I could make each of these just be a bit. So before I break it, by making some mistakes, I'm going to say copy test.cp to test.cp.backup, let's say. So test.cp. Okay. What I'm going to do here is I'm going to say, for this image, I really need only 1/8 of that space. So let me think about that for a second, how I actually want to do this. I kind of want to say I have something like class, let's say, bits. So public, private, do something like vector t and vec bits. Let's give it a size t width, a size t height. Okay, and then we're going to say default constructors delete. Okay, we're doing the destructor, which doesn't really need to do anything. I'll still define it though. Bits, size t width, size t height. We're going to say, oops. Okay, bits. Okay, bits. Anything there? Okay. I want to say invec.resize, and I'm going to say the size needs to be is the width times the height. And here's the fun stuff I get to do now with the bits. I'm going to say shift to right 3 times. And what this is going to do is imagine you have a number like 1, 2, 3, 4. Now, what if I told you to shift everything to the right 1 time? Like, imagine there's a bunch of decimal places here. And I'm just going to move all of these over past the decimal place. Decimal place. So what you get is like this, right? Imagine that shifting it over 1 time. Now say after you do that every time, you truncate the last value. So that's basically what it's doing. I'm shifting everything over, now you have this, it's going to become this, truncate. You can do the same thing in base 2. So what I was just doing here in like base 10 is like dividing by 10, and then I take the floor. Right? That's what it is. And I keep doing that every time I bit shift. So I do shift over one time, I do that, and I get like 1, 2, 3. I do it again, I get 1, 2, do it again, get 1, do it again, get 0. So in this case, it's in binary, so you have something like, you know, let's say 0, 1, 0, 1, 0, 1, 0, 1, right? And if I shift that once, I'm going to get 0, 1, 0, 1. Actually, it's over here like this, and 0, 1. Like that. Yeah. I mean, what I could have done is just say the same thing, 0, 1, 0, 1, 0, 1, 0, 1, and then basically just delete this, merge these, add a 0 there. That's what it is. And do it again, the same things that happen. But over here, you can imagine, like I said, dividing by 10 and then flooring. With binary, it's base 2 instead of base 10, so the same way, it's like floor of, you know, whatever the binary value is divided by 2. So for every time I shift it, you can imagine it's dividing by 2 and truncating. So right here, if I'm shifting to right 3 times, it's divided by 2, divided by 2, divided by 2. So if I'm divided by 2 3 times, it's the same as like, you know, a divided by 2 times 2 times 2, right? Which is 8. So a over 8, right? So if you want to divide by 8 really quickly, you can shift the bits to the right 3 times. It's way faster than dividing. Anyway, yeah, so what I want to do here is I want to say, let's say size. This is the space we need. So I'm going to say it's this. I'm going to say size plus equals. I'm going to say width times st height modulo 2 question mark 1, otherwise 0. So basically I'm going to add an extra byte if the width and height aren't an even multiple of 2. Like say I have something like, I don't know, 13 by 11, right? And like, what's that going to give me? I don't know if I can do that in my head. I mean, it's the same thing as like, what, 10 plus 1 times 10 plus 3, which is like 100 plus 30 plus 10 plus 3. So it's at 143. Yeah. Anyway, 143, you can't have 143 bits. In fact, I need to do this. Let's see. Yeah, if it's not divisible by 8. So if there's a remainder, then this would not be 0. If there's no remainder, it's 0. So if it's evenly divisible by 8, then it can fit in exactly how many bytes. So this right here, 143, I can tell you it's not divisible by 8 because it ends in an odd number. But if it were something like, I don't know, say 16, right? 16 is divisible by 8. I should say, sorry, 16 mod 8 equals 0. Because 16 divided by 8 equals 2. So 2 remainder 0. Anyway, if this is not divisible by a number of bytes, then we need to add an extra byte. So some of the bits in the last byte won't be used. Either way, we're going to resize it to st size, and we're going to fill them all with 0 by default. Cool. So now we need to do things like be able to paint with pixels. Let's say, I don't know, set. I'll just say set. Fine. Yeah. Void. We're going to say st x coordinate, size t y coordinate. Okay, I'm going to say void get size t x, size t y. So this will return a 0 or a 1, right? This will set to 0 or O or 1 apparently. Get a 0, 1 coordinates. Right, chords. Yeah. Okay, let's think here. So bits. Okay, so I called it invec. It's going to be a position stx plus sty times, I'm going to say m st width. So I actually need to save that. Over here we're going to have size t width. I'm going to say m for that. Remember, oops, m st height. Let's make these 0 by default. Yeah. After I do that, I'm going to say mst width equals st width, and st height equals st height. Cool. Okay. So, I want to set this with some value. I'm just going to say uint at. It really it's got to be a bit, but I can't pass less than a byte, so it's a value. Okay. Let me think here. That would be the byte offset right there. So offset equals that. I'm going to say bit equals st offset mod 8. So if I have all of this, it's going to be this shifted right 3 times. So divide it by 8. Divide by 8. Take the remaining, I'll say remainder, as the bit index. Okay, so yeah, the offset is going to be like the byte offset, and then it's going to OR equal because I'm setting it. Not necessarily though, because I could be setting it with a 0. So I'm going to do this instead of value. I'm going to say just a bool will be set. Okay, so if I don't like to do it this way, but just for now I'm going to do it. So if we're setting it, then we're going to OR it in. Otherwise, we're going to AND it out. Otherwise, invec st offset and equals. We're going to say, what do I want to do here? Right bit, but it's going to be the inverse of the bit. So we're going to say keep everything else set. Otherwise, we're going to set UI8 bit. But it's actually 1 shifted left by that. So we found the byte offset, and the bit we're worried about, we're going to reference it by having the bit 1, which is 00000001, right? And we're going to shift it left by whatever bit we're on. So if we're on, like, I don't know, bit 3, then this is going to go over 1, 2, 3, right? So instead of here, it'll be boop, boop, boop. So it'll become 000, 100, right? So anyway, that's what's happening there. In this case, we're saying instead of ORing it in, we're going to AND, which is going to return all the bits that are set in both things that we're testing. So if we have like 1111, that's 000, and we're ANDing it with, let's say, 1000, 000, we're only going to get 1 000, because the only two that are shared is like this and this. These aren't shared, and these aren't shared. So if I basically make it so everything but the one I want set here is set, then if anything else is set, it's going to stay set. And if this one isn't, or this is set, it's going to not be set now. So I'm basically clearing the bit that way. Okay. So I can either set it to be on or off. Let's mess with that function now. Let's say bool be set. Okay. And then get, I'm going to do basically the same thing here. Let's say, okay, yeah, invec position st offset and we say 1 shifted left by UI8 bit question mark. So if that's set, we're going to return true, otherwise false. Or I can even just make it like a AT. I'll return like 1 or 0. I don't know. Like even for this, I kind of want to make it be something other than a bool. I really don't like that I have to test with an if statement here. I almost want to make 2 functions out of this too. Like one's called set, one's called clear. Maybe I'll do that. I know it's kind of stupid and nitpicky, but if you can reduce this not to have a conditional statement, that's a lot faster. Conditional statements are really slow. Okay. I'm just going to do that. And for the sake of the test that I'm doing right now, I'm never really going to need to do anything but set. So I think that's fine. Okay. Cool. So at this point we can set, we can resize up to how big we want it to be. So I'm going to say something like bits b. I actually have to give it a width and height. I'm going to say it's 8 by 6. Now I'm going to say for, let's say, y equals 0, st less than 6, st plus plus. I'm going to say for st x equals 0, st x less than 8. Oops, st x plus plus. Okay. Now what I'm going to say is bits dot set. I'm going to say position stx sty. Okay. And by default they're already all 0. Because when I resize the vector right here, I initialized everything to 0. So I only need to set things. And only set them if they're set in this. So if that position stx plus sty times 8, then we're going to set it. Okay, so now I need to do something like show the picture from the bits class. So I'm going to say void show picture. I'm going to say just void const. I don't need to do anything special here. I'll give you no except. Alright. So here I'm going to say bits colon that. I'm actually going to, I think, where's that show picture I had earlier? Right here. I can just steal this basically. Okay. And I'm going to say, in this case, instead of doing this, how do I do this? I'm going to say get from stx to sty. So if it returns something other than 0, then return 1. Otherwise return 0. Okay. This is no longer required. Okay. So at this point it's bits.showPicture, which is b. Okay. And I want b.floodfill. I'm gonna have to implement that now. And show picture is gonna be b.that again. Okay, and actually I don't even need any arguments for this, because that's all stored in there. Same thing here, don't need any arguments for it. Over here, I will need the x and y position, whether I'm going to set it or not. Yeah. Okay, so let's take that floodfill function I made. I'm going to co-opt it. I'm going to say bits floodfill. And I'm going to get rid of these and that, and I think that's probably good. So in this case it's going to be something like set, I'm going to say stx, sty, but only if, right, create value to fill with, then we're going to set. So really, again, this flood fill should be flood fill with like setting or flood fill with clearing. Otherwise, clear, stx, sty. Okay. Anything else I need to care about? Well, this is called like mbec, right? Okay, let's do that. So right here again, every time I see vPicture, I replace that. I don't need this anymore because I've already co-opted that to the bits class. Okay, and then over here, let's cut all this out. Okay, put this way down here somewhere. Boom. Okay. Grab this. Stick that into the class. Okay. And then the other thing too is, when I'm looking at the width and the height, I actually need to replace that with MSD width and MSD height and all that. I don't think the height's ever actually tested, is it? No, it is over here, right? Yeah. Right. That's the only time it's tested, though. Okay. Over here, all of these. You know what? These never actually need to even be part of the equation. Right. So I do that for all of them. So classes make this a lot simpler because there's less arguments, but yeah. Anything else? Yeah, MSD width. Let's give this a try and see what I messed up. Oh yeah, here are errors. So no declaration matches bits clear as a void. Really? So STX, STY. Okay. Let's see if that's true. Yep. I never did specify clear. Cool. Okay. Okay, SD height, so I did miss one of them. SD2, I'm not returning something from a function, so let's do that. SD2. Return. Oh. Return that. Jeez. Okay. That was silly. Okay, 65. Alright. Okay. Okay, 67. Why doesn't it like that? We do have a get. So what's it complaining about? As this. Passing const bits as this argument. Discards qualifiers. Size D, size T. Const bits. Does it discard qualifiers? Oh, because I never flag. Okay, so if you pass a class object as a const, like I did in here, like get, see? Show picture. Should be const. I said it was const right here. But get, I didn't flag as const, which means it might actually mess with the object. So if this function is const, it can't call this function if it's not const. So I need to actually specify that in the definition and declaration. Okay, so 97 with, okay, let's do that. 97. It's going to be MSD width. And then 135. Oh, because I typed bits, the whole class name. Is that 195? What did I actually? 135 is what it was. Whatever. I just have to look for where it says bits dot something. Really? Huh. Well, where is it? Right here. Okay. Okay. And it's looping forever, so I definitely messed that up. That's interesting. Okay. So I loop through all the lines. Oh. It's greater than 8, yeah. That's nice. It's still looping forever, okay. Okay. So we want to flood fill with what it gives us. If it already is that value. Oh, you know what? Oops. So it's actually a stack overflow happening right there, probably. So I'm going to do get, let's say x and y. So if it's already set, we'll ignore it. There it is. Okay. Although, it looks wrong. It looks very wrong. So let's check over here. It's set here, I'm going to set it here. Uh-huh. Yeah. I feel like I'm missing something. 2, 2, 8, 6, width and height. Just make sure I got this right. Okay, so get the x plus the y times the width. Okay, and we're going to divide that by 8. 3 times, okay. Take the remainder as the bit offset. We're going to OR in that bit. Yep, at that offset. That seems right. So take the x and the y. X plus y times width, divided by 8. Mod 8 to get the bit offset. Oh. That would do it. That. Okay. Nope. I was kind of skeptical of that because I wasn't clearing anyway, but... Huh. Okay, so I get it. It's going to be x plus y times width, divided by 8, get the bit offset. So if the vector at this offset's byte, I AND out the current bit, and it gives me a value that isn't 0, then return 1, otherwise return 0. Okay. So if I get x and y, and it's already equal to the value to fill with rather, then stop here. Otherwise, set, if we were told to set, but if we're not told to set, then we're going to clear. Okay. Flood fill, x minus 1. Oh, I had to fix all of these. Oops. Get. So we're going to look at x minus 1, comma, y. In a way, this is actually easier to understand now, though. It's kind of nice. It's a lot easier to read. There's no math happening. So, comma, sty minus 1. Okay. Get stx, comma, sty plus 1. Okay, let's try that. And we're still not good for some reason. Is there anywhere else that I'm just accessing it directly as an array? Let's see if I have mvec. Where else is that? So resize it. So offset for that bit. Clear whatever that bit would be. So that offset ANDed with that bit. So if it's true, return 1, otherwise return 0. That seems fine. We're back to mvec. Yeah, so ever I should be using get, I am. I'm a little bit confused here right now, but it's okay. The other thing is in my constructor, did I set the width and height properly? When I was resizing everything. So whatever the width and height is I passed, I use that to get the size. That divided by 3 is how many bits, and if there's a remainder between the width times the height divided by 8, then add a byte. So resize that size and 0 everything. So the width is the width, height is the height. That seems fine. I show a picture, I'm showing from 0 to height. Okay, y plus plus. And I'm starting at 0, going up to the width. X plus plus. So, get x and y. If it's set, do 1, otherwise do 0. That looks right. Okay. Minus 1, plus 1. -1, +1. Okay. Defining it with a width of 8. 1, 2, 3, 4, 5, 6, 7, 8. That's right. And then 1, 2, 3, 4, 5, 6. Yeah. Okay. So it's from 0 to 6 rows. 0, 1, 2. Oops. 0, 1, 2, 3, 4, 5. Loss is less than 8. So 0, 1, 2, 3, 4, 5, 6, 7. That's right. I'm going to look at the picture at position x plus y times 8, which is the width. So if that's set, if it's a 1, or it's not a 0 really, then we're going to set x and y. And then, let's see, I don't really need this anymore. Like, that doesn't really do that anymore. Okay. Why is everything down here set? That is really perplexing me, especially since, like, this first one, everything's set too. That's the real weird thing. That tells me that right here something's wrong. It's like it doesn't realize that it isn't set, or I'm just messing up here, which is more likely when I'm setting the bits. So this vector should be of uint 8t, right? It is uint 8t. So when I set, at most I should be setting just 1 byte, but just to be safe, I'm going to say and 0xff. Just to be safe over here too, I'm going to say this and 0xff. Just in case the type's like promoted to something. It's not, okay, that's not the problem. Okay. Let's see, what else can we do here? Just make sure it's happening. Something really weird is going on with this being set, because it should only be setting like 1 bit of the whole byte. So the index under the vector, this whole thing divided by 8. The bit is the offset, divided by 8 takes the remainder. So vector or equals the bit in that position. Okay, well I want to do one weird test here. I want to say 1, 2, 3, 4, 1, 2, so that's 5, 6, 7, 8, 9, 10, 11, 12. So I should see 12 set. Set. How many is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it is only setting 12 of them. So it's definitely my set function that's messing up. In fact, I'm going to say break. Yeah. Okay. In fact, I'm going to say something like will be done equals false. I'm going to say be done equals true. And if be done here, break again. It's gonna break out of both loops. It's the first time I set something. Aha. So it's setting all 8 bits somehow. Why? Why would it set all 8 bits when I do set here? That's a bit strange. So I'm or equaling 1 shifted left by the bit number, which should only ever be, I have 1, then it'd be 1 0, then 1 0 0, then 1 0 0 0, then dot dot dot. How would it ever set the whole byte? That doesn't make any sense. setting, so I'll say ORing this value, ORing with this value. I'm going to say string PRI U8. It's going to be 1 shift to the left by U8 bit. Yeah. Okay, I just want to see what that says here. So we're using 4, 8, 16, 32. So 4 would be 1, 2, 4. So it's this bit right here. 8 would be here. 16 would be here. 32 would be here. Okay. So how am I getting all of these? Four, 8, 16, 32. So, huh. Why is this whole line affected then? Oh, it's also doing a 2. But yeah, so 2, 4, 8, 16, 32. It's kind of weird too that this is showing between this and here. Like, I would expect something like that to happen if it were multi-threaded or something weird, but... So what if I do this, flush, standard out. Okay. Yeah, why is it doing this, showing the whole image, and then... Oh, because of the flood fill. Right, right. So just ORing with 2, which should just be this right here, in any of these columns, should not cause all 8 of these to be set. 1, 2, 3, 4, 5, 6, 7, 8, right? I want to do one other thing here too. I'm going to say, where is it? Set. Okay. I'm going to save the x and the y that I'm passing. So, okay. Try U64, I'm going to say. U64. Okay. And just to be sure to have the right sizes for these, I'm going to say static cast into uint64t. Do it again. I'm going to use stx and sty. So I want to see where exactly in the buffer it's trying to set something. So at 2, 1, right? So 2, we're going to say 0, 1, 2. Or sorry, no, it's in the x. So 0, 1, 2, and 1. This is 0, this is 1. So 0, 1, 2. It should be setting this bit right here with the value 2, which should be 1, 2. It should be over here, not here. But it's setting this whole byte. Why? Well, let me think. If I have a width of 8, what am I getting here? I'm saying 2 plus y times 8. And the y is 1, so 1 times 8, which is just 8. So 2 plus 8 is 10. 10 divided by 3 is basically just going to, or sorry, not by 5, sorry, by 8. So it's going to say 10 divided by 2 would be 5. Divided by 2 again. It's going to truncate it, so it's going to be treating it like a 4 basically, because 2.5 is just 2. Divided by 2 again is just 1. So it's going to give me 1 for the byte. So this is byte 0, this is byte 1. That's good so far. And then the bit offset from that is going to be whatever, what was it, 8 plus 2, because it was 8 times 1 plus 2 is 10. So 10 over 8 is remainder 2. So byte 1, remainder 2 is bit number 3. Because it'd be 1 here, shift left twice would be a third bit. So 0, 1, 2. It should be this bit right here. And somehow the whole thing is being set. That is bizarre. Why would that happen? I kind of want to see what this is going to give me. So let me try this. I'm going to say the effective byte offset is -4 cast t. I'm going to say it is. I want to say ft offset. I'm going to say mvec st offset. Yeah, minus mvec 0. Which, I mean, it should be this anyway, but just for fun. Yeah. Byte 1 like I thought. Okay. And obviously, if I just do that, it's going to be the same thing. And if I do this, I'm going to say the bit offset is UI8. That's the UI8 bit. Okay. Okay, so let's look at it. The byte offset is 1. The bit offset is 1. That seems incorrect to me, because I have 2, 1. Which is 2 plus 1 times 8, which is 10. 10 divided by 8 should have remainder 2. So how am I getting 1? I guess bit 0 would be the first, and bit 1 would be the second. So that's right, 1, 1. So byte 0, byte 1, bit 0, bit 1, right here. And I'm ORing with 2. This is 0, this is 1, this would be 2. So that should be right. It should just be giving me this bit set right here. So why is the whole thing being set? Okay. Finally, I think one thing I want to do is, I'm going to say current byte value. I'm going to say URU8. Okay, and this is going to be this right here. Okay. Where's the current byte value? 0. So it is 0. And setting this bit right here is making the entire thing set. So it's like I'm ORing it with 255 somehow. Why would that be? Just out of curiosity here. So value equals 1 to the left by U8 bit. If I do this, or equals UI8 value, there is something weird going on. Yeah, what the heck? Or with 2? Why on earth would ORing it with 2 cause that to happen? Why? Okay. In fact, I'm just going to add value after ORing. I'm just going to say U8. Right. So over here, which is going to be in fact, if we just the offset. Okay. Test. 2. That is not 2. What the heck? I'm losing my mind here. So, this must be working then. It has to be where I'm getting the bit, then it's failing. So, I know I have the right byte, because I tested that up here. Do I have the right bit? So this byte being ANDed with 1 shifted left by the bit offset, which is the byte offset divided by 8 and take the remainder. What the heck? Why wouldn't this work? It's like I must be passing it some bad coordinates, or this is wrong. But this, I don't see how this could be wrong. Okay, I'm gonna say, just for sanity check here, getting, let's say percent sign value 64, comma, percent sign value 64. Okay, which gives me PRI U8, right? Let's just show that real quick. We're going to say static cast units equal t. We're going to say SDX. We're going to say SDY. And we're going to say mdec SC offset. What is that actual byte value there? Yeah. So 0, 0 gives me 0. 1, 0 gives me 0. A lot of zeros here. 2, 2, 2, 2, 2, 2, 2, 2, 2. So why am I getting 2 for 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, 1, 6, 1, 7, 1? Okay. If it's at return 1, that return 0. You're getting whatever is, you're getting whatever is, you're getting whatever. Okay. Why am I seeing a 1 before that? Oh, because I'm actually trying to draw it out, that's why. I think. Interesting. Yeah. So for 2, all of these are 1. Why am I getting... This is all for row 1. The whole row 1 is set, it says. I disagree. I don't think the whole row 1 is set. In fact, just for more sanity check here, I'm going to say, after this ends... Can I even do that, though? I want to say b.debug dump. I'm going to make a function that does that. This function is just going to dump the actual integer values of each thing. Const. Okay. So bits debug dump void const void. Okay, I'm going to say mdec. So I'm going to iterate through. So for const auto v value coming from mdec. We're going to say print out a character. So if v is set, then 1. Otherwise, that's not even what I want to do. Really, I want to just say PRI U8. Yeah. Comma v, right? And yeah, I don't know. I'll put a space between each one and then a line break or something. I want to say get. Get. Where is it? Over here. Let's stop with this, because that's spamming too much. So 0, 2, 0, 0, 0, 0. There's definitely something wrong with the get then, because 2 is right here. 0, 2, 0, 0, 0, 0. Why would it do this? I'm like losing my mind right now. There has to be something else weird going on here. So, I'm just going to say uint8, uint8 value, let's say it's a reference type, equals mvec at st offset. So, this is going to reference whatever that value is. If I wanted to, I could probably modify it. This is const, it has to be a const reference. Okay, so uint8 value, and, in fact, I'm even going to say this, uint8t, uint8, what do I want to call this? Let's call it and equals 1 left by u8 bit. It's really the offset, what the bit is. Okay, so value and u8 and, let's say, if that's true, return 1. Otherwise, we're just going to return 0. Why? X, Y. Is he doing XX or something? Where is it getting that? That's what I'm showing the picture, right? Oh, the dot in front of it. X, Y. 1, 0. X is 0 to width, Y is 0 to height. Get the XY coordinate. Okay, well, one other thing I want to test here then is checking bit whatever the bit is in byte this is going to spam a lot again. Okay, so we're checking bit u8 and in the byte being u8 value. Okay. Yeah. So bit 1 and byte 0. 0, 0, 0, 0. Okay, but now we're checking bit 2 and byte 2, bit 2 and byte 2, bit 2 and byte 2, bit 2 and byte 2. Why is it always checking bit 2 every single time? 4s, 1s, 4s, 8, 16, 32. The bit it's getting is wrong. So the offset divided by 8, that shouldn't be wrong. Okay. So we're getting 0, 0. I'm getting whatever to 0, all these rows 0. Okay, now we're in the triple point here, 0, 1. So getting 0, 1 in byte 2. Byte 2, byte 2, byte value 2, all of them byte value 2. Checking bit 2 and byte 2. Bit 2 and byte 2, bit 2 and byte 2, bit 2 and byte 2. This should really be 0 plus 8, which is just 8. which is bit 0. Bit 0 should not be set. Why is it getting bit 2? Why? Like, seriously, why? I'm like losing my mind right now. Okay, so instead of this, let's look at the actual offset and bit offset it's getting. So, okay, offset, let's say byte offset is going to be 64, let's say. Semicolon, bit offset, try u8. Okay. We're going to say, well, I'm going to drop this down a line because it's going to be really long. Static cast. I guess I don't have to, but I want to. I'm going to say offset. I'm going to say right bit. Yeah. Okay. I want line 2. Not so much. Okay, so byte 0s, byte 2. Okay. Byte 1, bit 1, byte 1, bit 1, byte 1, bit 1. Now we're in, yeah, every single one of these. Why? Like, seriously, why? Okay, let's just... The coordinates I'm getting are from here. Okay. Yeah. Okay, so we're at 1 here. So 0 plus 8. That should give bit 0, but it doesn't. All of these get 1 1. 1 1 1 1 1 1 1 1 1 1 1 1 1 1 1. How? Because it doesn't in any other point. Does it? 2 2 2 2 2 2. It's almost like it's just using whatever this is for both. Right? How about 3? Yeah, 3. 3. So whatever the y is, it's using that for everything. So x plus y times the width divided by 8. And then take the remainder of that. Oh, wait a minute. Yeah, okay. I did the order wrong. That's when I divide by 8. So I need to take the actual total value in the buffer, divide that by 8 to get the bit with the remainder, and then I need to do this. That was really dumb. Okay. Wow. So, same thing here. It's going to be a bug I have to fix everywhere. So, st offset divide by 8. Okay, so this is for set. I'm also going to need it in clear. I'm also going to need that in... Yeah. Okay, and then in get, I did it there already. Let's comment all of these out. Yeah, sometimes debugging can be a real pain. I won't notice something until I start seeing a pattern. And I'm like, where does that pattern emerge from in the code? I'm like, 1 plus banana doesn't equal purple. Okay, well, we're not much better off right now, but that's because because of all the wonderful things he does. I'm doing this and that. Okay. Don't need to do that anymore. Don't need that anymore. Okay. And now it works. Wow, that was exhausting. I wonder how much time that took. Either way, we're doing this with bits now. So it's taking 1/8 the space. Kinda nifty. Anyway. At this point, I went a bit overkill here. What I really wanted to show is how to do some bitwise operations with bit shifts, and with ORing things in, with ANDing things out. And I wanted to show recursion. The recursion part went pretty well, which is kind of funny because I usually have more trouble with recursion than bitwise operations. I just kind of did the math in the wrong order here. So, it is what it is. I'm debating whether I'm going to chop this video up a little bit, because I don't know how long you guys want to watch me debug this. But I think it's probably kind of useful to see. Even if people want to, they can just skim ahead, because you can see exactly what I did to try to debug, and people can, you know, maybe like it, maybe hate it, maybe adapt the ideas I had, things to test. But yeah, I'll just probably leave it at this. I think I did a pretty good explanation of what was happening, all the bounce checks I was doing. So, alright. If you thought this was helpful in any way, please like, comment, and subscribe. And if you have any feedback in general, also just comment. You feel free to tell me that I'm dumb and you could have done this better while blindfolded. No offense will be taken. Have a nice day.